Welcome everybody to CJUG today. And yeah, is it working, Cheng? Okay, cool. So welcome everybody to CJUG today. And today we have Billy Korando from Kansas City, and also Oracle Java developer here with us talking about Java 23. And thank you again to all of you for joining us today. And just also wanted a word to thank my helpers today. We have Che, who is doing the video streaming and recording. So if you have folks that, friends that are wanting to watch us, we are also on YouTube too, on our YouTube channel, if you search for that. And I can share the link later too. And also the link to this slide deck too, I'll share it with you. Okay, so and then that, and also we have Nick too here. Nick is also helping us today. So thank you, Nick. Yeah, so, okay, great. And okay. Okay. First of all, if you're interested in using, or if you have a need for JetBrains license, you're welcome to enter into this drawing. We'll have two for drawing at the end after the presentation, after Q&A. And you can, scan the QR code or just the bit.ly link and fill out just a very simple form giving your name and your email address. And then if you're the winner, then we'll mail the winning raffle or winning license to you, to your email. So, okay, good. All right. In case you miss, I will share with you the slide deck too. So, okay, good. Okay. Okay, just some housekeeping. Remember that if you haven't already joined the Chicago Tech Slack, is a Slack space that the community owns it. It's got over like 10,000 subscribers right now. And so you're welcome to join there. There are many channels now. And then we also have the Java off heap that continues with Freddie Gemay. He was the previous Java CJUG president. So he's still running that with Bob Holland and also with Josh Juno and Michael Manella. So, and if you haven't already joined us on meetup.com, please join us there, and that's linked. And follow us on Twitter or X right now if you haven't already done so. And we also have a Discord server too. So, you're welcome to be there, engage with the speaker today, with other speakers from previous talks, and I have special channels for each meetup too. So, and if you go to the one in the bottom, again, I will share with you the link, but that's the room. It's always labeled by the date and also the topic of the presentation too. So. Okay, and some community info. We are community partner of JetBrains. They donate like 2 free licenses to us every month. So then there's also a devitjobs.us. They have like jobs, not just in the US, but all over the world too. So if you want to join them, we're a community partner. And then there's also a huge We Are Developers conference in Berlin. If you happen to be in Berlin, they're offering some discount codes, so you can come to me if you are going to Berlin and wanting to attend that. As well as CoMotion, that they will be in Madrid and also Milan too. Actually, the Madrid one just happened, so Milan will be in October. So, and then this one is going to be interesting. It's by the legendary Venkat Subramaniam, as some of you may know, and he's come to us and speak, and he's a well-known Java. Well, not just Java now. He's a speaker, a really excellent speaker. So he will be running his conference in Denver, Colorado, on September 30th to October 3rd. And this is the QR code where if you scan that, you get more information as well as register for a $50 discount for the ticket too. So, okay. Good. Okay. And upcoming events in July, we already have a speaker committed. Is James Carman from Calibrity, the company that I just recently joined, and he's the Chief Technology Officer there. He's also an Apache PMC for multiple projects too. And then other confirmed speakers, we're going to have Venkat coming too, and most likely in October. We haven't nailed down the date, but he will be in Chicago in October. And then Alina, also, I've been talking with her, but for her, she's based in Switzerland now. Otherwise, Alina is from Ukraine. Yeah, so we have friends from Ukraine in the front seat too today. So yeah, so Alina will be great to talk about GraalVM. So we're trying to schedule with her. As well as from Oracle, there's Josie Pomal too. And so we have to schedule with him when he's based in France. Yeah, and Bill is calling. Yes. Still trying to think if we should do an unconference style. We call it unmeetup at some point. If you're interested. We started trying out with AI Camp yesterday, and everybody liked it a lot. So we're gonna continue this to try it out somewhere else. So, okay. And if you're interested in speaking at CJUG, you're welcome to submit your topics. Send us email to present@cjug.org. And if you are seeking jobs and if you're recruiters, you're welcome to join our CJUG group on LinkedIn. This is the link to join the group, or you can search for us on LinkedIn too. And it's just a platform where you can exchange information with one another. So, and okay, good. I think you're still scanning someone. Good, okay. Oh, one more. Okay. Okay, so just a note too on some of our sponsors. So past sponsors still want to mention because JFrog was sponsoring us for the past 3 years. But unfortunately, now they're not able to sponsor us this year, but hopefully they said they may come back again next year. And then also with Fusion off too, they were also kind of very generous to us. And soon to be, we'll have a new gold sponsor, Aiden. They are a payment services company that's based in the Netherlands, but they are worldwide too, their services. So. And friends of CJUG, we have all these, worldwide Java community. Just want to remind you because some of them are doing meetups in a virtual format as well. And I also listed Kansas City Jug, which is, Billy is a Jug leader there. And also the other Jugs, Atlanta, Boston, Garden State in New Jersey, New York Java SIG, the oldest one in the US for Java Users Group, and then Pittsburgh too. And now our speaker today, Billy Korando. So Billy is a Java developer advocate from Oracle. He specializes in Spring and continuous delivery and many things too, but I know Spring and continuous delivery is his thing, his chops. Yeah, that's right. And he has published a course on Pluralsight, and he was previously a developer and a consultant for over a decade. Experience with building software systems for many different industry verticals that include insurance, finance, government, and more. He's also a Jug leader and a co-organizer of the Kansas City Java Users Group, and also a co-organizer of the very popular KCDC, Kansas City Developer Conference, which will be next week.
Yeah.
So I'll see him again next week. Outside of work, Billy is a diehard fan, and I know so well because every time when there's a football season, he'll be like glued to the TV on the weekends. From what I know, so he's a diehard KC Royals and Chiefs fan. So here it is, and the stage is all Billy's.
Thank you.
Welcome.
Thanks, Mary. Definitely an easy time to be a Chiefs fan for sure. We've had some success recently. All right, go ahead. There we go. So, this is to Java 23 Beyond. Oh, I should also mention, Mary was mentioning how they're looking for speakers. So that's actually how I got started in presenting, was presenting at my local users group. It's a great way because you're kind of, well, I don't know if it's better or worse, but you'll be presenting a bunch of friends and people that you know. So I guess if it's too bad, like just having to leave to a new city or something. But it's a great way to get started. It's also a great way to, if there's maybe a subject that you want to learn more about, nothing motivates you to become more of an expert on it than doing a presentation on it. So that's also a good motivation if you really want to learn something. So definitely consider taking Mary up on her offer, presenting at CJUG. Again, great way to get started presenting if you're interested. So important information, please at any point ask questions. Actually, so just back a couple of days ago on Tuesday, I flew into here from Seattle, but on Tuesday I was presenting at Seattle, so it's a little bit of a connection beyond the fact that they're both called CJUG, just Seattle is SEA. Mary was also mentioning that Freddie Guime, who used to be the president of CJUG here, is also now helping run CJUG in Seattle. So a little bit of a connection as well there. For this presentation, you can actually go to it right now online, and I believe it should be fully identical to what you're seeing on here as well. So if there's any additional information, you just want to go back and look at something, you can go to that link and watch it there. So another small conference is coming back called Java 1. It will be March 17th through 20th at Redwood Shores, California. We're still working on some details, but as we learn more, you can go to oracle.com/Java1 to follow along. All right, and also, if you'd like to know more, we have our site, dev.java. I have it on my back here, but the team I'm on at Oracle, the Java DevRel team, we rerun this site and we publish tutorials, and we also have like a community page that connects you with all the jugs around the world, which is really nice. We have insight.java. So that is where we like to post a lot of articles from the engineers that actually work on the JDK. So they, every so once in a while, there's like a new feature coming out. They may give like a really long post kind of covering that feature and information behind it. So definitely check out, there's a nice aggregator site. And then we also have our YouTube channel and our podcast. All right, for agenda. I'd like to start with a brief review of some key changes between JDK 11 to 17, because it helps also set up some key themes that is continuing in Java here on through even into 23. And then from there, we're going to new features, API updates, new runtime features, things that are going away, and then also a brief look into the future. Just real quick, so are many people here still on Java 8? JK? No, I'm glad to see. It does definitely seem, it seems like really over this past year, a lot of organizations have really started to move beyond Java 8. So how many are 11? 17? How many people are on 21? Okay, good. That's good to see. I'm really glad to see though that we're finally, as an industry, because that's actually been pretty consistent, where it's usually only a couple of people are still on JDK 8, finally moving beyond and getting to 11, 17, and 21. So key changes though in JDK 11 to 17. The first one I want to cover is text blocks. These were added in Java 15. Enhancement proposal process, and the purpose of that is to help raise awareness around a feature or a change coming. So oftentimes it's going to be some sort of addition, but there could also be deprecations and removals, and of course we want to have Java developers aware of these changes coming. So if you were to go here to OpenJDK, openjdk.org JEPs 0, or just JEPs, it will give you the full page of all the JEPs that have been done. And then if you were to provide like a number, like in the case of 378, that will take you to that specific JEP. And then this can provide you a lot more background and information about this feature or whatever I am talking about, then I can kind of go into during this presentation. Otherwise, we'd be here for several hours, and I don't know if anyone is quite that enthusiastic. But text blocks, simply put, they are two-dimensional strings. And along with that, they also somewhat relax some of the formatting requirements. So in a in your standard string, one-dimensional string, you would have to escape this double quote, because strings are delimited by double quotes. So of course you would have to escape that. But then there'll be other things like for tabs or something, you would have to do like a /t if you wanted to get all this formatting for new lines, /n. And what that all added up to is there would be a lot of just mechanics and a lot of distracting additions to this code that would make it very easy or make it difficult to really understand what's going on here. Even this simple JSON message would be quickly unreadable with all that. And then in that unreadability, it'd be very easy to accidentally forget to include a comma or something like that. So it's not necessarily just about less typing or anything like that, but it's also less typing in the service of making code easier to read and then also less error prone. And again, that's a big theme for a lot of these changes. Along with that is updates to switch. These were added in Java 14, JEP 361. And the changes include the new arrow syntax. So now if you match on a case, only the code to the right of this arrow is executed, because with the switch syntax with the colon, which is still completely valid, you're not going to have to update that or anything like that. You would have to include a break if you didn't want to have it fall through to the following case, which is pretty much the case in like 99% of use cases involving switch, where you would not want to have fall through. And so if we were to have the break after each of these cases, well, quickly this becomes, again, much harder to read. And it's also very easy, because I know I've done a couple of times where you excluded a break and then all of a sudden you have a bug in production where you're matching or you're executing multiple cases when you're only expecting to execute on one. Also with the updates to switch was the ability to write them as an expression. So here, this is a statement. All we're doing is doing a print line. But if none of these match, the code, the application can continue running without actually executing them. With an expression, well, one of these has to match because we need to set the day value. And so often that means you would have to include a default case, but we'll see a little bit later on, starting in Java 21, how that is no longer quite the case. Then there's sealed hierarchies, or sealed classes as they're called in the JEP. And so what they are is the ability to define, or for a class to define who can extend off of it. So in this case, I have a user, and user only allows admin, customer, or guest to extend it. Sealed classes become more practically useful starting particularly in Java 21. But before here, back in 17, if you're still just on 17, at every organization, or I guess some of you are students right now, so when you join organizations, they all have certain domain concepts. Here, again, I'm using like user, it could be transaction type, it could be order type, and there'll be just something like, okay, hey, at our organization, we only have like these 3 or 4 order types. But before sealed classes or sealed hierarchies, there was never really a way to write that into code. It's just something you would need to maybe kind of communicate with other developers. I mean, there would be only so many certain classes you could have, but with a sealed hierarchy, you could actually really define and constrain it to say, like, no, we only have like these 4 transaction types, and you can go to like the super transaction type, and it can actually even show you that, like, oh yeah, these are the only 4 transaction types that we have. But anyways, these classes that can extend off a user, they would then need to either declare themselves as non-sealed, like in the case of customer. Effectively, that makes it a normal class, so any class can extend off of customer. There's final, that's not new, so nothing can extend guest. Or you can also declare the class as sealed, as in the case of admin. And you'll notice here, up in user, I am using permits. So when I am referencing a class that's outside of the source file of this class, then I would use the permits to say, like, okay, these classes and these other source files are allowed to extend off of user. However, if I was in the same source file, like I am here with user, to reference classes that extend off of it, then the compiler assumes these are the only classes that are allowed to extend off of admin, in which case I don't need to use the permits clause. So permits is not actually required when using a sealed class. Then there's records. And records, they allow for the simple defining of a data class, as we see up here with person. So obviously a major benefit is that you can define a data class in a single line, but that wasn't the goal. The goal of records, it wasn't to compete with Lombok, or Lombok's pure goal is just to reduce the verbosity. Records also had was aiming to improve the data handling within Java. So records are transparent modeling of data as data, and that's accomplished because records can only be their superclass is always going to be records. So as a result, they can't be extended. They're abstract and implicitly final. All fields are final, but they are only solidly immutable. And you can't declare instance fields. So all of this is in service to where you can just look at the definition of a record and get a clear understanding of the data it contains. Then there's also pattern matching, for instance. This was added in Java 16. Pattern matching has become a much bigger story within Java since then, but it all started with instance of. And so instance of isn't necessarily the most popular thing that Java developers use, but if you've ever used it, it often had the very frustrating thing where you would do okay, is this variable an instance of this reference type? And if it is, then within the following if, you would then do the casting to that reference type and then assigning it. And it just, it's like, no, I already know this is an integer. Why do I need to recast it? It was a very frustrating pattern that just had to be done because of the constraints of Java. But now we have pattern matching, for instance, of. So you have your predicate here. So your predicate is doing some sort of test. And if that test is successful, then it will assign the result of that to the pattern variable. And this pattern variable is what's called flow scopes. And that means this variable is in scope wherever the compiler definitely knows that it is been set, or wherever that predicate is definitely known to be true. Typically what this means is in the following if block, or the following block after an if case, then that I will be in scope. Technically, you could get a little crazy with it. I could do like if I could put a not in front of this and then throw an exception, and then technically I would be in scope for the rest of at least that code block. Don't do that because that will be very confusing to a future developer. But particularly the records and pattern matching, and then also being combined with some other features, is about building out Java's data-oriented programming paradigm. And this is particularly more useful in modern software development. So back early on, when I first started programming back in 2000, or as a professional in 2008, and many people here have probably also started before then, we were programming in big monolithic applications, to where oftentimes you'd be mutating the values within an object by other processes and communicating all within the same kind of memory runtime. But kind of going to the 2010s, things like microservices became popularized. Later on in 2010s, things like serverless and lambdas became very popular. And so the sizes of applications started to shrink considerably, to where you're very often interacting at those data boundaries, where you're interacting with a database, or you're interacting with a web service, where you're often having to do data transformation. In which case, being able to more easily translate data between these layers becomes much more important. All the same, so one of my colleagues, Nikolai Parlog, put together a really great, actually what is now a 7-part series covering this. So if you wanted to learn more about that, check that out as well. Then lastly, as far as a review, there's also the API updates. So the Java doc team has done a great job. So I know it's a lot of people are already on JDK 17. So let's say you're considering to look to see going from 17 to 21, you can kind of come in here and just actually select to see okay, here's all the new API that has been added between 18 and 21. So you can see what is being added. You can also go into deprecated, exact, kind of same behavior, where you can check off, maybe between which versions you're updating between, again, to see maybe, okay, these are some of the things we need to look on getting off of as we are updating. So a lot of really nice features. I mean, there's been many other features added to JavaDoc over recent releases. And of course, all this stuff, if you're working on libraries within your organization, or maybe you're just like a full-on library developer like Mary CTO, as you mentioned, he's an Apache contributor, where, he's probably working on libraries that are very widely used, where providing good documentation can be helpful. A lot of these features, all these features can be also used as well. It's not somehow limited to the JDK itself. All right. So let's start getting into the newer features of Host 17. So as mentioned, pattern matching has become a much bigger story within Java now in recent releases, and that's still going to be continuing into the future as well. But a big one is pattern matching for switch, which was added in Java 21, JEP 441, or I should say finalized in Java 21. So when you're doing pattern matching with switch, it must always be exhaustive. So even if it's being read as a statement, it would still need to be exhaustive. And it can also handle null within the switch as well. So here in my test example, we have like an interface shape, and then triangle, circle, and square all implement shape. And we can then see here, it's like, okay, we have, passing shape. If we match on triangle, then, or if that shape is of the type triangle, then we can set it to T. And then we have like a when clause where we can also inspect that value to see like, okay, if the area of this triangle shape is greater than 100, we'll do something different. Otherwise, for any other cases, then we'll do, we'll just match on this. That's very nice, because otherwise, if with this, we would have to have like an if statement within this switch case, which again starts to become very hard to read for developers and somewhat error prone. But as mentioned, so in this example, this switch is a statement, but even though it's a statement, it still needs to be exhaustive. So in this case, I have a default case as well. We can also see here how we can also handle null directly within switch. So if for some reason there's a concern that shape could possibly be null, instead of having to wrap this in an if statement to say like if not null, then we run the switch, we can actually handle it directly within the switch itself, which, again, is just that much easier and cleaner to look at for other developers. As mentioned, though, so often it has to be exhaustive, and oftentimes that can mean you would need to include a default case. However, in this now, I am writing the shape interface as a sealed interface. And because the compiler knows that only triangle, circle, and square are implementing shape, and that's the only classes that implement it, and then I am covering triangle, circle, and square. How some of these features are kind of coming together. And it's not just, and the benefit here isn't, you just don't need to write a default case, is that, okay, so like, let's say in the future, we start supporting a new shape, pentagons, or we get really crazy and start supporting hexagons or something like that. If we were to add these new shapes, and maybe we forget to, and this is, in different areas of the code base, and we forget to update the switch, instead of needing to rely on unit tests, which unit tests are great, but you may forget to probably write it all. You can't even get this to production because the code won't compile. You begin a compile error here because you want to be covering all possible use cases. So that is a nice way, again, of how it's not just about less typing, but about writing code so that it becomes a bit more concise, and then it's also just less error prone. You also have record patterns, and essentially what record patterns are deconstructing a record. So, of course, right up here, or well, I guess not technically constructor, but you kind of write out a constructor, you're newing it, you're passing your values, and then this is just the inverse of it, where you're extracting the values out of it as well. So with record patterns, it does positional matching, and it just needs to match this. Needs to be a compatible type. In this case, I'm using var or local type inference, which then automatically makes sure it matches on the type. But like this would otherwise need to either be string or object or something that's compatible with string, which we're like, is that be about the only two examples. But then the name doesn't actually matter, which is why I deliberately used different names here. Though you probably would still want to both match on the name just for consistency and probably not use local type inference, but instead maybe directly match on the type as well. You can also include record patterns within switch, as I'm doing here, where also you can do a guard condition where like if the middle name isn't empty, then I will print it out one way, including the middle name. Otherwise, I won't reference the middle name and print it out a different way. So actually, I should have probably continued to use this example, but you'll probably also notice here, even though I'm not using middle name, I still had to define it. And that could be a little confusing or just otherwise unnecessary to do. So something that was then added in JDK 22 is unnamed patterns and variables. So using a somewhat different example, here in this example, we have like a somewhat complex object where I have like a customer, which takes in a name, address, and billing, which are all records themselves. But then here in this if, the only thing I really care about in this if is the billing address. But even though that's the only thing I only care about here, I still have to go through and define all of these different variables, which again is a bunch of typing and a little bit confusing. So like, okay, I'm only using billing address here, but I'm referencing all these other variables. Like, are we supposed to use them or not use them here? Now with unnamed patterns, we can just replace those with underscores. So less typing, easier to read, and then it's also much clearer in its hint to future developers that no, the only value I care here is address. We don't have to worry about these other values. Also, so here, like I'm still kind of having to explode it somewhat out, but like in a slightly different example, maybe I only cared about name, then I can just reference the name from customer, and I don't have to explode out the billing or the address within customer. Unnamed variables can also, or it's unnaming isn't just limited to patterns, but can also be for other variables. So here, I'm doing like an enhanced for loop across names, but for whatever reason, I'm not going to actually reference the n name itself. So I can just replace that with an underscore. And also here in a handling exception, in this case, like a client maybe passes in an incorrect value, in which, in that case, printing out that stack trace isn't really useful. You're just wanting to send back a message to a customer saying like, hey, provide us the correct value, and it will be successful. In which case you can just say, okay, I'm going to underscore just to make it clear I'm deliberately not really working with that exception. Just to be clear though, there's no performance gain to this. Like the JVM still handles that variable. It's just kind of like an anonymous variable. It's like in debugging purposes, like you can still see it in the debugger and all that stuff. So like, don't think like, oh, I'm going to be saving on memory or sometime processing time by doing that underscore. You won't. It's purely for reading perspective. For API updates, sequence collections were added in JDK 21, which is up 431. So sequence collections, a lot of them is just kind of promoting methods from lower classes within a collection hierarchy that kind of are just really purely quality of life things, like being able to add an element to the start of a collection or to the end of a collection, which is typically the default behavior, or getting the first element or getting the last element. Probably the most beneficial one is doing reversed, just because reversing the order of a collection could be very annoying to do. So now you can just simply call it not reversed on it. Well, then that's just that much easier. And then a lot of similar corresponding behavior was also added to map as well. So probably the one important thing to understand, so it's kind of, this is showing you where these new interfaces live within the hierarchy. So like a lot of times when you're writing a list, like array list is like the default list implementation many developers use, or linked list, in which case they both benefit from the new sequence collection. But on the other hand, the default map many developers go to is hash map. Well, hash map doesn't have a defined order because it's hashing the values within it. So you would need to either use a linked hash map or, of course, a sorted map, which of course does have a defined order to take the benefits of the sequence map. So that's just probably about the only notable thing worth pointing out here. So virtual threads. So this was one feature that a lot of Java developers were really looking forward to. For senior developers, and particularly ones that have been like involved in the JDK. Yeah, this is the main outcome or the main feature of Project Loom. By no means the only feature, but this has been waited for I don't know, close to 10 years probably. All the same. So the first delivery out of Project Loom, what it does is it's a lightweight thread model. And eventually it's going to be combined with structured concurrency and scope values, which I will cover a little bit later. But to kind of briefly cover what is actually happening here, I put together just a little bit of visualization. So in Java, all things run on threads, whether it's a simple hello world program or any other application you write. And threads in Java have a really pretty close one-to-one relationship with the underlying operating system thread. And that's a relatively both expensive and relatively constrained constructs. So to create a new thread, I keep needing to look it up, but it's like several hundred kilobytes to maybe about a megabyte in heap space that's being added when you create a new thread. But then also the number of threads you can actually run on a system is relatively limited. Maybe a few thousand or so, somewhere in that area, which if you're running web applications, that can quickly become a constraint because often web applications have a one-to-one relationship between a new request comes in and then a new thread is spun up to handle that new request. Now, if all those threads was just running the entire time, like, maybe you're doing AI work and you're spinning a bunch of threads to learn or something, all those threads are probably working the entire time. So the fact that you have a limited number of threads probably isn't an issue because they're actually also using up all that CPU. But for, particularly the web application case, oftentimes there's going to be a lot of idle time within that thread because if you get a request coming in, a lot of times the first thing you're going to do is going to do some sort of database call to be like, oh, okay, I'm looking up Billy's information about his profile, and then you're going to be maybe calling some other web service to be like, okay, he wants to buy this something off of Amazon, so we're going to call this other service to like look up prices or look up for setting up an order or something like that. And so while that is happening, that thread is just sitting idle while it's waiting for a response. So the reality is for like a lot of web applications is that you could be fully thread constrained, but your CPU utilization could be very low because those threads are often spending a lot of time idling. So what Loom is trying, or what Loom did now at this point, is they split the concept of thread into two distinct concepts. There's the platform thread, which is basically still like threads from the past, this one-run relationship with the underlying operating system thread. But then they also have a virtual threads, which exists purely in memory, and they run on top of platform threads. And like a virtual thread, at its most base level, I think it's like 4 kilobytes of memory. Now, of course, if you add elements like thread local or something like that, that will increase its size as well. But just the virtual thread itself is an extremely lightweight concept. So what the JDK does then is as it gets virtual threads, it will put them into a queue. And then if there's available platform threads, it will then add those virtual threads in the order that they were added to the queue to the platform threads, and they will have them run until it runs into a point where it's being blocked by some sort of operation. And then at that point, if there's other available virtual threads in queue, then it will put that virtual thread into queue and then have that other, bring that other virtual thread off a queue and have it running. But then it'll have a listener to say, you know, like this light green virtual thread up here, have a listener saying like, okay, when it's starting to get data back to it, at which point it becomes eligible to be requeued. So yeah, so what you get here is instead of having all this wait time, now you're getting much better utilization of your system resources. And what the real benefit here is, so obviously this idea, particularly web applications being somewhat thread constrained, wasn't new. And that's why things like reactive programming were starting to become very popular, because they were trying to solve for that issue of being thread constrained by running everything as futures. But the difficulty there is you would have like a request come in, you send it off as a future, but you would run into some error, and it can be very difficult then to debug what's happening. With virtual threads, though, all that context stays with the virtual threads, even though there's one platform that's running up here and another one down here, and then this virtual thread started off here, let's just say platform thread 1 and platform thread 3. The context and the stack and all the thread local stays with that virtual thread. There would be an ID to say which platform thread it's running on, but you know, that's for debugging purposes. It really should never matter. Next, we have the foreign function and memory API. How many people do like Java native interface work? Usually there's one, no matter the size of the room. But in this case, my background is also as a web developer, so I never needed to really work with the Java native interface. The foreign function memory API is an enhancement to the Java native interface. The Java native interface had some issues with a somewhat clunky usage. It could also have some security issues because like you're working with raw memory on a system. So this foreign function memory API is just seeking to make that both safer and it also have a much more consistent API. They also provided the JExtract tool. But the JExtract tool can read the headers off of a native library and they construct a Java API for interacting with that library. So this is a much easier way of interacting with the native libraries on your system. Finally, to kind of go back, or not finally, but to go back to JavaDoc, they also added Markdown to JavaDoc. This is being added in JDK 23. And so, yeah, Markdown, like right now, a lot of the markup is handled with HTML, but HTML isn't the most readable. You know, the easiest example would be creating a link where you do like href and the name of the link, you know, close it, and then provide the text of what you want to show, and then close it with the anchor tag. Usually it's very easy just to read Markdown as Markdown. So that's very good for if you are wanting to provide something more complex that can be beneficial for Markdown. You can still read it like this within the IDE itself. And anyways, to use that, you would need to denote that line with triple backslashes. Getting into runtime features and tools. We have a bunch of CDS updates. So anyone heard of CDS? That's fine. That's usually what I get, where it's between 0 and 1 people. So CDS, it actually goes all the way back to the JDK 5 days. Whenever your JVM would start up, it would load a bunch of files off the file system. Now, back in JDK 5, which was, I think, 2008, no, probably even before then, it's probably like 2004, I think it was released. All the same, back then, your it was hard drive disk where you had the magnetic platter where it was spinning around and it was being read off of. And that meant file back then was particularly expensive. So what CDS tried to do is it created a pre-processed archive of all the files that JVM was needing to load on startup, and it would memory map it, which was much faster to load from than trying to load all those file systems off the hard drive. So since then, JDK 9 or JDK 10, we extended CDS to where you could also do that same mapping, not just for JDK files, but for your actual application files. So like if you had like a Spring Boot application, you could create a CDS archive of like all the classes you're loading from all the different jars and create an archive off of that. And kind of iteratively, they've made it easier to work with to where, so initially when that was added, called App CDS, it was a 3-step process of mapping all the classes, creating the archive, and then reading that archive. Now it's just a 1-step process with the autocreate shared archive. And what it'll say is like, okay, this shared archive file, foo.jsa, does it exist? If it does exist, we'll just load it. If it doesn't exist, then it'll create the actual archive and then store it at this location of where you define shared archive file. And so what's really nice here is then that way, like your CI builds and your production deployments can actually match. You're not going to have like, oh, in the CI build, we're going to build the archive, and then in production, we're going to run it. Having the exact same command line you're using for running it being identical obviously has a lot of benefits when it comes to maintenance and making sure and troubleshooting. Also with CDS, so there's a new project that is starting to really pick up steam called Project Loom. And the goal of Project Loom is improving the startup performance and time to peak performance of Java applications. And that's going to be doing through a lot of what's called like time shifting of work, so where you would have like a training run of like, okay, we're gonna, create some sort of flow to run through this application, and the JVM will follow it, be like, okay, like these methods are used a lot, these methods are being compiled as a native code, and so on, and it can save all that information into its own archive file, and they can load from that archive file to where your startup will be that much faster, and as well as your time to peak performance. If you're not familiar, so the JVM has what's called the JIT compiler, where it's following how your code's behaving, and if like certain methods are being used a lot, or if certain paths are being followed. So like if there's an if statement and like the past 1,000 or 1 million runs, that if has always followed the true path, then like the JIT will compile that code to simplify it to be like, okay, we're just going to assume it's true. We'll kind of ignore this check and run it more quickly. That's kind of what I'm talking about here. You can save that behavior so that way it doesn't have to go through that to where it's in a more optimized state from the very start. And then I guess the last thing on that Project Loom is hopefully they'll have EA builds here sometime this summer. So if you want to check it out, it'll be a lot easier to do as well. Simple web server. Actually, this presentation, which is using Reveal.js, also just like how Mary and the CJUG presentation was earlier, is actually running off the simple web server. All the simple web server is it provides a way of just serving up files of a file system. Do not use the JWeb server in production. There's no security around it really or anything like that, so it's not production ready by any means. But part of it, like it can be for more veteran developers, it can be useful because it could be used as like a mock endpoint, or for simple prototyping. But like a lot of the major motivation behind this is also for students, which many are in here are students, because oftentimes like an early lesson for students is just to simply serve up some files off your file system. And before this was added, a lot of times for students to do this, they would need to use like Node or have to go download like some file system or application server like Tomcat or whatever it might be. This is just say like, hey, we can provide this tool directly with the JVM, and like it was a very low cost or within a JDK, and it was very low cost as well. So back in JDK 15, we added a new garbage collector called ZGC. And ZGC, it is a almost entirely pauseless or almost entirely concurrent garbage collector with ultra low latency, where it had sub-millisecond pause times, and then it also could handle a heap of up to 16 terabytes in size as well. So back then, it was what's called a single generational garbage collector. In 21, they updated it to be a multi-generational garbage collector. And without getting too much into garbage collectors, the kind of main takeaway is that it just uses a lot less memory now, or it's a lot more memory efficient, I should say. I should have actually need to update the slide. But if you're on 21, if you want to use a generational garbage collector, you would need to include the additional argument of plus Z generational. Otherwise, you'd be using a single generation garbage collector. But starting in 23, if you just use ZGC, then that would default to using the generational garbage collector. And then the goal is to eventually deprecate and then remove the single generational ZGC, in a future release. Region pinning for G1. This is again something useful for Java native interface developers, wherein you can pin certain regions where you're setting aside memory for working with native objects, and then by marking that the G1 garbage collector, which is the default garbage collector for the JVM, would know to not interact with those regions. And then there is the launch multi-file source code programs. So back in JDK 11, we added the ability for the single file source code applications, where if you just were doing your simple hello world program, instead of having to run that program, instead of having to do Java C, get the class file and then run the class file, you could just do Java on the source code file itself, and then the Java compiler automatically compile it and then run that program. Now we're able to do that for, multiple source code files. And how that would work is, you could pass in multiple files directly if you wanted to, but actually the Java compiler would be pretty smart to be where it's okay, I have my main program, and then following, the package structure, if I'm referencing some other classes, it can find on the file system where those classes are located again, if it's following the same package structure, and then compile and run them as well. So that's very nice. Again, very useful for students as they're just starting to learn, because now, it just makes it a little bit easier working with multiple source code files, but also even useful for more veteran developers, because now Java is becoming a much more practical option for writing simple shell scripts or something like that. Before, you maybe would need to go to Python or Bash or something like that. I used to know Bash back in college. I've since forgotten it all. So it's actually kind of nice that Java is becoming a more practical choice in this regard, because sometimes still need to write a simple application for maybe standing up a project or reading a CSV file or something like that. And Java can be a more practical option for doing that. For deprecations and removals, I'm sorry, Windows 32-bit developer, or if you're still on Windows 32-bit, that port has been deprecated for removal as of JDK 21. So yeah, time to upgrade to 64-bit systems. Getting into the beyond, so what is coming to Java in the future? I was talking with a attendee here earlier, and he was asking about how to best handle concurrency in Java. And so technically, as of right now, that would still be the executor service to handle the running of multiple threads and returning them as well. But soon, it will be with structured concurrency. And so the benefit of structured concurrency is it allows you to more reasonably work with breaking down a task into multiple units, executing them concurrently, but then better reason about it. Because kind of one of the issues right now in Java is, okay, so you have maybe multiple items executing concurrently. What do you do if you have these 4 tasks executing concurrently? They all have to succeed, but then one of them fails. So in that case, you need to roll it back, but also you want those other tasks to just cancel as well, because there's no point in having them to continue if you need all of them to succeed together. So like here in this example, you have a structured shutdown on failure, where if any of the tasks within the scope was to fail, then it would automatically cancel all the other examples. You can also have like a shutdown and success where, okay, you have 5 tasks executing concurrently, but the first one that succeeds could just say like, okay, that succeeds, I'll take the result from that and then cancel the rest. Like a good example of that, if like maybe you're writing a weather app and there's like a lot of different options for getting the weather back within the location. And so you can call out like all 4 or 5 of them, and like the first one to succeed, you'll just take the result of that and then give that to the user for wanting to know the local weather. So like, right. So I think there's maybe one other pre-done example. I think like example where making sure that all of them are successful before continuing. But this can be extended to match whatever the use case you might need. So like, let's say you have a use case, to go back to the weather example, maybe there's like 4 or 5 local options for weather in your area. Maybe you at least want to get 2 back, and then you'll average the difference between those 2 to return that weather to the user. But like you need to at least get half back. So you can extend your structured cast code to be like, okay, at least get half back and maybe wait an extra second, because, ideally it'd be great to get all 4 back, but you don't want to wait too long before you turn this over to the user. So a lot of this is extendable. It's not like purely shut down a success, like getting the first result back or getting the first failure back and filling everything. You can extend this behavior to kind of match what it's ever needed for your organization. Somewhat related. So as mentioned before, virtual threads were added, and they will allow you to spin up a huge amount of threads within your JVM, to where it can be very practical to have hundreds of thousands or even millions of threads running within the same JVM. Now, right now in Java, it can be somewhat common to use like thread local to store data relevant to those threads that you're going to be executing on them with. But when you have hundreds of thousands or possibly even millions of threads, copying like a value across all those threads, that can start to take up a lot of memory. So that's where scope values come in. To kind of go back to the concurrency example, structured concurrency example, let's say, and this is also using earlier this week at CJUG, because Freddie Guillemet, he works for a company called Expedia, which obviously does travel. And so with that is like, okay, so like I was just traveling between Seattle, Chicago, and Kansas City here this week. I could call to a company like Expedia and be like, okay, give me the prices for flights between these 3 cities. And, they'll call out to like American Airlines, United, Delta, Southwest, Frontier, all the different airlines. So putting something like that value in the thread local, that is a little bit wasteful of memory. So putting that into a scope value where it's like, okay, within this scope, this value is going to be relevant, and it's just an immutable value that's going to be read from. So it's very quick and thread safe across all that. But it's only going to have just one instance of it, which will then, of course, save on memory versus, again, having it stored as a local value, where that value is going to be copied across all those threads, taking up more memory. The vector API, I think some people I was also talking about earlier with attendees, was talking about, or that's right, this is the joint Java ML group, where calculating vectors and all that stuff. My background is not at all in AI or ML, but I do know the vector API is very important for Java being able to better support machine learning and AI, because it's much more CPU efficient. Anyways, vector API will remain in incubator status pending Valhalla starting to deliver, or at least getting its its deliverables into preview status because it will so fundamentally impact the vector API. Project Valhalla, if you're not familiar, it is about densifying Java's memory model. So like right now, except for the 8 primitive types of sort, int, long, byte, boolean, char, that's a whatever, and the other one, whatever. Everything else is a reference type. And so reference types, they have identity, and there's a lot of overhead associated with that. But that doesn't necessarily, all these different reference types don't necessarily need to have that. For example, there's like the integer, like the autobox type around ints. Like it doesn't, like 100 is 100. You don't need to have identity associated with that. Or another one could be like local dates, where, there is only one June 20th. You don't, that's going to be consistent across all. There may be, a specific time within an area, but overall, the concept of June 20th is atomic, so you don't need to really have identity associated with that. So Valhalla is allowing you ways of removing identity when you don't need it, along with a lot of other changes, but that would fundamentally impact Vector API. So until Valhalla starts delivering, Vector API will remain in incubator status. The ClassRail API, fundamentally, this will make upgrading between releases even easier because it will allow the JVM to actually inspect to see if the underlying classes, if they have any changes to them. Most of you developers won't actually interact with it, but I would definitely recommend checking out this video, again, by my colleague Nikolai Parlog, where he explains it and the benefits that it would still have to Java developers, even if you aren't interacting with it directly. Stream gatherers. So streams, if you use them, there's the collect method, which is a method where you can just take in, collecting all the values out of a stream, and then performing whatever arbitrary code you want against it. But collect is a terminal operation. Gatherers are effectively creating an intermediary operation out of collect, where you can take in all the values, perform whatever arbitrary code you want against them, and then return whatever arbitrary values out of that you want. So that can be very nice and useful. Flexible body constructors. So here's an example. It's something just simply saying positive big integer extending off a big integer. So before being able to have a more flexible body constructor, you would have, if you wanted, you would have to first call super up here, which is potentially unnecessary work if the value is below 0, in which case you would have to throw exception, saying like, hey, this is not a positive value, we're declining it. So there's a couple of ways of handling it. Like one way would be to create like a static method, like verify it's positive, and then call that within the super reference. But it's not the cleanest way of writing that. So fundamentally, what flexible body constructors are allowing you to do is just allowing you to have calls before super within a constructor, just so that way you can have, like in this case, actually checking to make sure a value is a valid value before calling super. Also, so initially this was just allowing statements before super in a constructor, and now with the update of JDK 23, it's also allowing values to be assigned before super in a method as well. So definitely check that out more, or check out that Jeff if you want more details on it. Primitive type patterns. This was Java 23 as a first preview, and simply all this is doing is allowing you to use primitives, as I talked about a little bit earlier, within a pattern. Before you couldn't do that, now you can, and fundamentally it's just resolving a weirdness around pattern matching of now actually not allowing you to do primitives within it. This is something I'm actually very excited about. I know it's like a bit of a dense title, but again, there's people who are maybe more relatively new to Java in here. They're still students or recently students, where this is, of course, like the first program you're going to learn in Java, or any language having its own equivalents. But this is very dense to learn if you actually want to learn what's going on here, because we're introducing things like access with public. We're also introducing classes. We're introducing static, void with return types, method arguments, of course, methods themselves, referencing static values as well as system out. So there's a lot going on here. So for a new student, like they're just learning Java, maybe having never done any other programming before, to actually understand all that's going on here could be several weeks of instruction to really understand everything here. And, that would be a very difficult way to learn programming, especially because you wouldn't necessarily have context to understand the importance around all this stuff. So actually I'll go a little bit backwards through this, but eventually the goal is to get to where you can just simply write void name and then print line, and it kind of have ways of gracefully kind of ramping up new concepts as needed, such as like slowly adding like reference to classes and access and all that as well. So Brian Getz, he is the chief language architect of Java, and I have a reference here a little bit later, where what he calls is about paving the on-ramp of taking someone from writing their very first program here, again, just simply hello world, and then being able to easily add new concepts on as they are actually needed and relevant to a student. I think it's very useful for, again, improving Java's popularity to students. But even if you don't care about that at all, it's also very useful for more veteran developers because, as I was talking about earlier, Java is becoming a more practical option for writing scripting languages, or for handling what's typically handled by scripting languages instead, because not having to always write out a class if you don't need to can be kind of nice if you're just, again, trying to do some sort of simple scripting behavior. Also, a change added in JDK 23 is a new read line, because also if you needed to take in values from the console, you're having to write out like a buffered system writer or whatever. It was always far more complex to take in values from the console than it ever seemed needed to be. Now you have a very simple read line, and then it'll print out what's your name and then accept an input from the user. But yeah, to get more of an idea of like the overall conception behind this, check out this article from Brian Getz. It's actually hard to believe it's been like 2 or 3 years ago now when he wrote it, but it lays out the overall vision behind these changes. That said, these are some follow-up links. So for maybe everyone on here that's on JDK 17 and hoping to make that jump to JDK 21, so back in last September when JDK 21 was released, myself and my team we released a number of videos kind of covering both the changes between JDK 17 and 21, and then also like maybe some of like the things you need to be aware about, for upgrading as well. Again, the link to the JEPs, to JDK 22 release notes, that's obviously still the most current version, and the other links I talked about earlier. But yeah, thank you. And then here's the link to the presentation. Of course, if there's any questions, I'll be happy to answer them. Thank you. Any questions though, or? Yeah. Oh, yeah. Uh-huh. Yeah. So the question was, can about virtual threads and structured concurrency, can they be used together? And yeah, that is the actual goal, because they go together extremely well. So yeah, virtual threads, as I kind of covered a little bit earlier. Let's go back at least to whatever. Virtual threads, as I covered earlier, was about splitting up the concept of threads into 2 distinct parts, but to have a much more light thread that exists in memory. And because now threads have become a lot cheaper, creating and breaking up a unit of work into tasks that we can execute concurrently is a lot less costly. It's like, okay, like, yeah, this task could have been broken up and, executed in parallel, but it wouldn't have been worth the trade-off because spinning up a new thread is somewhat expensive. Now, because it's so cheap, now structured concurrency becomes a lot more interesting to split it up. So yeah, structured concurrency and virtual threads go together. I think again, my colleague Nikolai in a video, he said they go together like peanut butter and jelly, which is a good way of putting it. But really underlying it, you wouldn't necessarily need to be aware because like the virtual threads can be created by the JVM or something like that. You wouldn't necessarily need to be deliberately, knowingly creating virtual threads. You can if you want to, but that can all be handled on the underlying system kind of in the background. Yeah. So like I said, the goal here is that when you break up this unit of work to be executed on multiple tasks, you just want to have ways of more about handling what should happen to make sure like, okay, we'll make sure we wait until all these tasks are complete before continuing, or if like one of these tasks fails, what to do then, or if one of them succeeds, then ignore the rest and we'll just take the first success. Structured concurrency is providing you more tools for of reasoning and working with tasks executing concurrently. Yeah. Mm-hmm. No. So Spring Boot entities, like those are often mutable features. So like a lot of times like it's mapping to like an underlying database feature. And like if you update the database, then like it wants to update that entity. And in which case it would need to be mutable. And that doesn't match with the goal of records. So yeah, they can't really be used as entities. I remember kind of messing with that a little bit earlier on when records first came out. And yeah, they just don't go together because fundamentally entities are supposed to be mutable. So, any other questions? Yes.
Virtual threads and its ability to roll back. Like action. Yeah.
Probably it's been a little bit since I last used transactional in a Spring application. I do know like a lot of like database drivers and stuff like that do need to be updated to more properly take advantage of virtual threads. So like, but they aren't in conflict. Like there shouldn't be any detriment to using a virtual thread in that context. But it may not also really have much benefit either. So it just might kind of depend. Yeah. So. All right. Cool. Thank you very much, Mary. And thank you very much. And I'll feel free to ask me questions later.